on number 17, we got 5 to the third power to the third power. Now when you got power to a power, when you're raising a power to a power, you multiply. So here I've got 5 to the third times 3, which gives me 5 to the 9th. Again, don't multiply 5 times 5. I don't want a whole number. I don't want you to stick 5 to the third in your calculator and tell me that it's 1 million something. All right, I know it's a really big number. I want you to simplify it in exponential form and leave it as 5 to the 9th. Here, simplify the expression 8 times x to the 0. Now what you got to be careful with here is x to the 0, anything to the 0 power is 1. Now this is 8 times x to the 0. This is not 8x to the 0 power. This is not all that being raised to 0 power. So the answer is not 1. What you've got to do here is realize the x is the only thing raised to the 0 power. So it becomes 1. So I get 8 times 1, which gives me 8. A lot of people miss that on the midterm. So be real careful on that particular problem. Number 19. Again, it says do not use negative exponents. Now the way I like to do this one is I got 4 t's on top, 7 t's on the bottom. Now we can do it like we did earlier, where we just write out all 7 t's on the bottom, all 4 up here. But here, these 4 simplify with these 7 and leave me with what? 3 on the bottom. So basically I get 1 over t to the third. That's the quickest way that I know how to do that type of problem. The other way is use the rule. The rule is you got t to the fourth, and you're going to subtract the 7, because in division you subtract exponents, and you get t to the negative 3. But don't leave it like that, because what does it say? Do not use negative exponents. So I got to take this answer, reciprocate it, because this is really over 1. Remember, any variable or number you have always has a 1 under it if it's just like there. So make sure that you can put it as a fraction and you reciprocate it, you get 1 over t to the third. This to me is a little bit easier. Number 20, multiply and then if possible simplify. And you can do this a couple of ways. You can simplify first, then multiply. Or you can just multiply it straight across and then simplify. I'm going to go ahead and multiply it straight across, because some people get lost in the simplification process. I'm just going to multiply numerator times numerator. 8 times 5 is 40. P to the fourth over p times 9p is 9p squared, because p times p is p squared. Then I can simplify from there. Well, 40 over 9. Well, 40 is not divisible by 3, and 9 just has 3 times 3. So really 40 over 9 is as simplified as that gets. Well, look here. I have 4 p's on top, 2 on the bottom. So I got 40 over 9, and then look, these 2 simplify with those and leave me with 2 on top. Again, I could have done p to the 4 minus 2 and gave me the p squared. Either way you want to do that, you can work that one out. And that would be my final answer. 40p squared over 9. I'm multiplying 2 binomials. Now multiplying 2 binomials, we have 5x plus 3 times x plus 8. Now some people have been taught this as the distributive property. Some have done the FOIL method, which is first, outer, inner, last. Doesn't really matter which method you use. If we take this first term, multiply it times the first term in that parentheses, that's where the FOIL first term comes from. But basically we just distribute 5x times x, which is 5x squared. Then we take that same 5x and distribute it to this one here. That's where called the outer terms. This is an outer term, that's an outer term. So we multiply those two together and we get 40x. Then we go into the inner terms. We got this positive 3. We got to distribute it. 3 times x is 3x. That's our inner term. Then our last terms. Well, it's the last term in this parentheses, last one in that parentheses. 3 times 8 is 24. So basically we take each term and distribute it to the term in the other one. Then we combine like terms. Right here, those are like terms. So we got 5x squared plus 43x plus 24. And some of you might say, well, 5x squared has an x in it. Isn't it alike? No, because this is an x squared and these are x's. So you can only combine if they have the same variable and exponent. Or if they're just flat out whole numbers, you can combine all the whole numbers together. This one's a special one, so if you went through the study and everything and you learned the pattern, you could actually do a pattern here, or just multiply it out. I think it's just as easy just to multiply it out. X times x is x squared. X times a negative 11 is a negative 11x. Then we take our second term, positive 11 times x is a positive 11x. Positive 11 times a negative 11 is a negative 121. If you look right here, what happens is the middle terms zero out. We've got a negative 11x and a positive 11x. That becomes 0 and leaves me with x squared minus 121. That's called a difference of squares. It is a special one that has a special pattern, but like I said, you really don't have to memorize that pattern. You can just multiply it out just like you did number 21. We have w minus 2 squared. The squared means you're going to multiply it times itself. So you need to rewrite this as w minus 2 times w minus 2. Again, you could have memorized the pattern on this, but like I said, it's just as easy. Just go ahead and work it out. W times w is w squared. W times a negative 2 is negative 2w. Negative 2 times w is negative 2w. Negative 2 times a negative 2, negative times a negative is a positive. So we have positive 4. Combine like terms. The negative 2w's are like, so we put w squared minus 4w, because when you add same signs, you add and keep the sign. So it would be a negative 4w plus 4, and there's my final answer. Be real careful that you don't just distribute the square. That's where a lot of people make a mistake here and get w squared plus 4 instead, and they lose the middle term because they forget to FOIL it or distribute it out. Division. Now when you're dividing a monomial into a polynomial, or a trinomial in this case, what I like to do is I like to separate it. Because if you remember, when you're adding fractions, you have to have a common denominator. So what I'm doing here is I'm pulling them back apart. Okay? What I could do is I could re-add all these up, since they all have the common denominator. I could re-add them up and get this. But now what I'm trying to do is pull it back apart and see what I started off with initially. So I pull it apart, I put the common denominator under each one, and then I'm going to simplify. Now the little method I taught you a while ago, there's 4 x's here, 2 here. Those 2 simplify with those and give me 2 left. So that leaves me with 2x squared. I don't need to put the 1 on the bottom because they're not going to do that on the answers. If you put it on there, you're not going to get counted off for it. We got x to the third, x squared. Well, there's more on the top than there is on the bottom, so these 2 will simplify with that and leave me with just one of the x's up there. Still have the 7. Don't lose the numbers, the coefficients there. If you do, that could be a problem. Here, we got x squareds and x squareds. They're exactly the same. What do you get when you have something over itself? A 1. They simplify to a 1, and 1 times 3 is 3. So here's my final answer to this question. Now every once in a while you might end up with still something left in the denominator, depending on if this denominator has a bigger exponent than the one in the numerator. So watch for that. Alright, that's it for this video. We'll see you at the next one, number 25.